Assalamualaikum warahmatullahi wabarakatuh. And today my group will present about Fourier series. My group consists of 3 members, and my name is Danish Lukman bin Khairuddin, and my group members name is Muhammad Nazim bin Azli and Nick Ridwan Firdaus bin Ramli. A Fourier series is an expansion of a periodic function into a sum of trigonometric functions. As shown here, this is the Fourier series formula. So for task 1, we will use the function of x squared plus 2, and the range of x is from -2 to 2. After that, when we substitute the value of x into the function, we will get the value of the function according to the value of x, which is 6, 3, 0, 3 and 6. From here on, we can plot the graph and we will get this shape. So this function is an even function because the graph is symmetry on the y-axis. For task 1 number 2, we will use the function of x cubed minus 2x, and the range of the x is -2 to 2. When we substitute the value of x into the function, we will get the value of -4, 1, 0, -1 and 4. So after that, we can plot the graph and we will get this shape. So this function is an odd function because the graph is symmetry on the origin. For task number 3, we will use the function of x plus 1 squared, and the range of x is from -3 to 1. When we substitute the value of x into the function, we will get the value of 4, 1, 0, 1, 4. After that, we can plot the graph and we will get this shape. So from this graph, we can conclude that this function is a neither function, as the graph is not symmetry on the y-axis or the origin.
Hello, my name is Muhammad Nazim bin Azli and I will explain about task 2. Task 2 asking about expansion of the function in Fourier series in a cosine series, a sine series and a Fourier series, neither odd nor even. The function that I will use is fx equals to 2x squared. So these are the general formula for Fourier cosine series, Fourier sine series and Fourier series, neither odd nor even. As you can see, for Fourier cosine series, Bn is equal to 0. For Fourier sine series, A not equals to 0 and An equals to 0. So let's dive into the Fourier cosine series expansion. For cosine series, you need to substitute the functions into A0 formula and into An formula. After calculating the A0 and An for cosine series, you will have to substitute into the general function. It's the same as cosine series. You also need to substitute the function into the Bn, because for sine series, A0 and An is equals to 0. For neither odd nor even series, you are required to calculate all the An, A0 and Bn, and then you will have to substitute into the general equation.
Hi, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good evening. My name is Nick Ridwan Firdaus bin Ramli and I was assigned today to complete task 3 for MAT565 assignment. Okay, so for the task 3, we gonna solve problem from chapter 2, the Fourier series. Okay, so as it's given A1 and B2, and we have to determine that the Fourier series for function in standard form until third harmonic, which mean easily said till C3. Alright, so here our Fourier function question and answer, as you can see here. Now, what does that mean? Essentially, we are expressing a periodic function as a sum of sinusoidal function, and we are going up to the third harmonic in this case. Alright. For anything, I remind you guys, Fourier series is a way to represent a function as a sum of sine and cosine function. The key idea is that periodic function can be expressed as a combination of these simple sinusoidal waves. Right. To find our Fourier series, we need to calculate the Fourier coefficient. This coefficient tells us how much of each sine and cosine wave is present in our original function. The formula for this coefficient might look intimidating, but fear not, we'll simply it for the third harmonic. Integrate, we'll calculate the A and B coefficient that correspond to the sine and cosine terms for the till the third harmonic. So as you can see here, we substitute. First, we find A1 and B1, and since we already have the B1, we just substitute it into the formula using the cos, because to find A, you have to use cos, and for B, you have to sine. And for searching C, which is coefficient, you have to use the formula square root A square and plus B square. Okay, as you can see here, as for C1, we got 2.07, and since A1 is the result of tangent A1 over B1, so that we can inverse that tangent to get A1, which is 78.8 degree. So that's all for the explanation. You have to repeat the same process for A2, B2 and C2 till A3, B3 and C3, which is C3 represent the third harmonic.